Today we're going to be talking about types of proofs. We're going to cover just a couple of topics that are in 2.5. I'm going to tell you briefly about them, but the majority of this information is actually going to come from 2.6, okay, which is talking about algebraic proofs. So first of all, let's talk about what is a proof. And the definition is in your book. But a proof is going to be a logical argument, and so that's part of why we've been talking about logic. Had a whole couple of sections talking about logic, in which each statement made is supported by a reason. And that reason is already going to have been shown to be true. Okay, so we're putting in parentheses here, which is already shown to be true. Okay, so let's talk again about the important parts here. It has to be a logical argument, meaning we're going to be using the inductive and deductive reasoning that we've already been looking at, primarily deductive reasoning. It means we're going to be using things like the law of detachment and the law of syllogism. Those are going to come up again. And we're going to have some statements, okay, and we have to support those statements with a reason. Okay, so it's kind of like if you were a lawyer and you are trying to prove that someone is guilty. You can say, they held the murder weapon, but unless you can prove it by saying we found their fingerprints on the murder weapon, then it doesn't matter if you are saying that they held it. We can't prove it unless you have some evidence. So those reasons are the evidence. Okay. The last thing that's really important here is your reason that you're giving has to already be shown to be true. So you can't just make something up and assume that it's going to be okay. We have to be able to say that that's okay. So in the same example, fingerprints weren't considered very important right at the beginning of all the CSI kind of stuff until they were able to prove, and they had to do a lot of research to do this, they were able to prove that everybody has different fingerprints. So at that point, fingerprints became really important. But they didn't stand up in court as a reason to say somebody was touching something or had held something until they could show that everybody's fingerprints are different. And so we could prove, if your fingerprints are on here, it was definitely you that touched the item. Okay? So we're going to talk about some different types of proofs. And so these are our types. And we're going to go through them one at a time. So first, let's look at a paragraph proof. And the key here on this one is the word paragraph. This one is in 2-5. And a paragraph proof is an informal proof, which involves writing a paragraph to explain why a conjecture for a given situation is true. So, for example, if they gave you this equation, 3x minus 9 equals 0, and they want you to prove that x equals 3, you would have to walk through the steps of saying, first you would do this, then you would do this, and at the end, look, our solution is x equals 3, which is what we were trying to prove. You always have to start with the given information, okay, and you always have to end up with whatever they are trying to prove, whatever they're asking you to prove, okay? And that's going to be true no matter what kind of proof we're looking at. So basically, you need to be able to recognize these proofs. We're not going to practice writing them a bunch, but I want you to know that it exists, and I want you to be able to recognize it if it pops up. Okay, so that's our first kind. The second one we're looking at is a flowchart proof. And again, this one is in 2.5, so you just have to recognize it. And it's going to give a concept map. And I gave you a really simple one here because I was trying to use the same example for all three of these. Some of these flowcharts can be much more complicated. So you might see, some of them, say if you have this, then this happens, and then depending on what happens from there, you could end up with one of these two options. So they can be much more complicated. I just want you to know that, that's a possibility. Okay. So it's going to still give statements and reasons, and your statements go in the boxes, okay? And then your reasons are going to go over here on the outside of the boxes. And sometimes they use squares, and sometimes they use circles. The shape of the box is not important. It's just that there's a box. And these are usually really helpful if, like, the order is really important. One thing leads specifically to another, or if you could have two things that led into creating one item. That's going to be really helpful. And we'll talk about some of these later and say, hey, this would be a good, candidate for a flowchart proof. But mostly you just need to be able to recognize them. Okay? The one we are most interested in is a 2-column proof. The last one here. It gets a big smiley face, because we're going to use this in a bunch. It's going to be your BFF. Okay? And so this one is going to be a proof, and it is a formal proof. That just means this is the kind of proof that if you were trying to prove something to someone who's really important, then you would probably be using a formal proof. If you were using this, like if you become a math major in college and you have to write a dissertation or a paper, and you have to use a proof in there, this is the kind of proof you would use because it's a formal proof. Okay? And so a couple of things. Everything on these is going to be organized into 2 columns. Okay? Your 2 columns will always have the same names. You always have statements on the left and reasons on the right. Okay? The first box, okay, will always have your given information. Sometimes there's more than one piece of given information, and you can either list all of those in one box or list them each in their own separate box. And we'll talk about times when it's easier to do it one way and times when it's easier to do the other, but either one is fine. Okay? And then whatever they're asking you to prove is going to go down here in the very last box. Now, you're not always going to know how many steps it is. Sometimes you will, sometimes you won't. But you should know that the last statement will always be what they've asked you to prove. You will also notice that the word prove doesn't show up in here in the proof at all. Okay? Given shows up as a reason. Prove or proof is never going to show up inside the 2 columns. Okay? So you'll notice the word proof not in here. Okay? And that's really important because that's one of the common mistakes that people make. Okay? So next, we are going to look at an example. So let's start with an algebra example. They tend to be a little bit easier. So we're going to make, I'm going to give you 2 pieces of information. I'm going to give you the given, and it is an algebra expression, equation. Okay, so they're always going to give you a given and a proof, and you're going to start off by drawing a 2-column table. Okay, it's kind of like a T-chart. On the left will always be statements, and on the right will always be reasons. Okay? Your first statement will always be the given information. And you want to number these. I suggest putting your numbers, in a circle or something so that you make sure that they don't accidentally get mixed in with the numbers in the equation. So I've seen that happen before. Let me give myself a little more room. And then the corresponding number on the other side will always have your reason. And so for the first one, it's always going to start off with given, because you can't start a proof unless you've been given something. Okay? From here, for an algebra proof, we're just going to solve the left-hand side the way that you would solve any equation. And some students find it more helpful at this point to go ahead and solve the entire algebra problem first, and then to put in their reason. So that's the way we're going to work it out right now. So first, we have to distribute. Okay, and we have 2 things here to distribute. So we're going to have 2 times 5 is 10. 2 times negative 3a is negative 6a. And then we have negative 4, don't forget this negative sign. Negative 4 times a is negative 4a. And negative 4 times 7 is negative 28. That all still equals 92. Okay, so then we're going to go ahead, and I'm alternating colors here just so that you can see what they are. You don't have to do that on your paper. I just don't have the lines like you might on notebook paper. So our next step is going to be to combine our like terms, right? And so we're going to go ahead and do that. So 10 minus 28 is negative 18, and negative 6 minus negative 4, those both have a's, are going to be negative 10a. That equals 92. And step 4 is going to be, we have to move this 18 over. So we're going to add 18 to both sides. Okay, and so that'll cancel here, so there will be no 18 left there, and we'll have negative 10a equals 110. And then for our next step, we're going to divide by negative 10 on both sides. And so when we do that, we get a equals negative 11. Okay, so now we have to go back and fill in our reasons. Okay, and so the trick here is going to be, what did we do to go from the previous step to get to this step? Okay, so we're saying, okay, to go from step 1 to step 2, we had to distribute. And if you look in your book, at the beginning of 2.6, there should be a pretty little chart. It should look something like this, where it has all these properties on the left. On here, I've also included an example, and I'm trying to print these out so that they're small enough where you can put a copy into your notes. So if you want to leave room for that at the end of this section, that would be helpful. If not, you can pause it here and copy this down into your notes, or you can just look in your book in 2.6. It's there. Okay. So we distributed, so that's going to be the distributive property. That's the algebra property that lets us distribute these numbers through here. Okay. Then we look and we want to say, okay, next, what did we do to go from step 2 to step 3? And we combined our like terms, and those are all on the same side of the equal sign. And so there's not a property listed for this one on here, so you may either put simplify or you may put combine like terms. I will accept either one of those. And so we're going to use either of those as fine. Okay. Then to go from step 3 to step 4, we added 18 to both sides. And so this is the addition property because we are adding something to both sides. And that's why that actually wouldn't work for the last one, because we weren't adding or subtracting something on both sides of the equal sign. Okay. And then last but certainly not least, we divided by negative 10 on both sides. And so that is the division property of equality. Okay. So we will do a geometry example tomorrow in class that uses some angles, and we'll look back over this one to make sure we understand all the steps. And I look forward to seeing you. Thank you for listening, and I hope you have a lovely afternoon.